Hi everyone, I hope you're having a great day today. So we are going to be going over 13.4 notes and the worksheet, part of the worksheet anyways. So I'm just going to start off with 3 things to remember about tessellations, since that is what 13.4 is about. It's all about tessellations. So the 3 things are: they must fill the entire plane, must be congruent, and must not have any gaps to be considered a tessellation. So we're going to go over the first part of each activity, and the page numbers will be 259, 260, 261, and 262 in chapter 13 in mathematics activities for elementary school teachers workbook. So starting off, I'll just read the first part of the directions here. There are many intersecting questions related to tessellations. For example, which regular polygons will tessellate? To find out, complete the following experiment. Carefully cut out the regular polygons and sort them by shape. Mark a point P near the center of a separate sheet of paper. Start with equilateral triangles. Place a vertex of one of the triangles on P. Continue placing triangles edge to edge to cover the region around P. Record your results in the table. Continue this process until you have tested each regular polygon. So starting off, we're going to go over the triangle. So the measure of each interior angle, number of angles at P, sum of the measures of the angles at P, does the polygon tessellate, are going to be the 4 categories that we're looking at. So I do have a visual representation of this question right here. So I have 6 equilateral triangles, and so they are each 60 degrees. As you can see, there is point P. I put point P in the middle. So then going back to our question, measure of each interior angle. So that is 60 degrees. Numbers of angles at P. So looking back here, I have 1, 2, 3, 4, 5, and 6. 6 angles total. And then I also have the sum of measures of angles at P. Okay, so there's 60, 60, 60, 60, 60, and 60. So that means 180 plus 180 is going to give us 360 degrees. All right, 360 degrees there. So you guys can see it better. Here we go. All right, so does the polygon tessellate? Yes, it does. Yes, all right. So that's the first part of that question. And so you guys will just need to fill out the rest of the chart up here. And then another thing that you guys might also need to, with the nonagon, decagon, and the dodecagon, I would recommend using the n-2 times 180 over n, and then that'll give you the best way to solve that with the nonagon, decagon, and dodecagon. Okay, so moving on to the first one here. What must be true about the measure of an interior angle of a regular polygon in order for the polygon to tessellate? So, like right here. So it has to be 360 degrees, 6 sides, and 60 degrees. But for the square, for example, square isn't going to be 60 degrees, so it's going to be 90 degrees. And there's going to be 4 angles. And so then 90. So you have 4 angles altogether, and that's going to make 360 degrees. So 90 plus 90 plus 90 plus 90, or 90 times 4. 360 degrees. So yes, that is going to tessellate. Okay, so moving on to which of the regular polygons tessellated. We'll just need to fill out the rest of the chart. So I'll let you guys do that part. And then make a sketch to show that each polygon in part A will tile the plane. These are regular tessellations. So the thing that makes a regular polygon is that regular polygons have all their sides are congruent and all angles are the same. So an equilateral triangle, that would be considered a regular polygon. A square would be considered a regular polygon. Okay, so then I'll have you guys answer that one too. We'll fill out with that information. Okay, so moving on to page 260. So use your result from exercise 1 to show that the polygon in exercise 2 are the only regular polygons that will tessellate. So looking back, you'll need to use the first chart to help you answer that. First chart to fill that out, and then we'll fill out that. That'll help you fill out questions 1 through 3. So find a different way to arrange 2 squares and 3 equilateral triangles around a point P to create a tessellation. That is using this sketch right here. Make a sketch of the tessellation. So they would like for us to, rather than having it horizontal, maybe try drawing it or sketching it vertical or diagonal and see if the tessellation still works. The next question, number 5, construct 4 more tessellations that include more than one type of regular polygon. So you can use a square, a triangle, back to our list here. You can use a hexagon. Those are my recommendations for that. So a hexagon, square, and a triangle. Okay, so moving on to question 6. Which of the tessellations you created in exercises 4 and 5 are semi-regular? If a tessellation isn't semi-regular, explain why not. So then you'll just build the tessellation that is wanted for question 5, and then explain why it's semi-regular or why it's not. And so it does need to include regular polygons with that. So going on to 7, use a ruler to draw a non-equilateral triangle on an index card and cut it out. Trace around your triangle to create a tessellation. Be sure corresponding sides of the triangles are edge to edge. Compare your triangle and tessellation with those of several classmates. Were there any triangles that would not tessellate? Will any triangle tessellate? If so, show how to arrange the triangles around a point to create a tessellation. So for this part, I'll show you what I created. For this part, mine did tessellate. Okay, so I just showed you pretty much the same example I just did. Isosceles triangles. They all have different measures of sides and 60 degrees, interior angles there, and still created 360. So mine did tessellate. Okay, so number 8, draw a convex quadrilateral on an index card and cut it out. Trace around the quadrilateral to construct a tessellation. Be sure to join the quadrilaterals edge to edge. Do you think any convex quadrilateral will tessellate? If so, show how to arrange the quadrilaterals around a point to create a tessellation. If not, explain why or why not. So you're pretty much just doing the exact same thing rather than triangles in this example, doing it with quadrilaterals. And to see if they can tessellate or not. So using translations, following step 1, step 2, step 3, and step 4. This is my example of the extensions. So there's my original image there. As you can, it unfortunately wasn't able to fit on my entire paper, but if I rotated it over, and down and over, and then down and over. It's an example how to do that part of the worksheet. And the last part, using steps 1, 2, 3, and 4. My example of this, of using rotations. So there's my original. And I follow it around and I rotate it. Kind of fits together, kind of like a puzzle. Around and around. And I ran out of room, but as you can see, if I did go again here, it would match up. Just really quick, 3 things to remember about the tessellations. They must fill entire plane, they must be congruent, and they must not have any gaps.